Swayam Prabha. Digital India. Educated India.
So, last class I was talking about the beam resting on two parameter model. So, today I will discuss that how we can solve this type of problem and what are the boundary conditions under different loading conditions when beam is resting on two parameter model, and what is the difference between the beam resting on spring and beam resting on two parameter model. So, this is the problem that this is two parameter model, over that beam is resting and over that there is a UDL Q is acting. So, now the expression for two parameter model is given as Q is equal to K into W minus G H d square W d x square. Okay. So, I am talking about the plane strain condition. Okay. So, that means here Q equal to K W minus G H d square W d x square. So, this is the expression for two parameter model, and the expression for the beam equation is E I d 4 W d x 4 plus your K W that is equal to Q. Okay, so, this is the expressions we are talking about that for beam when it is resting on Winkler model. Okay. So, now we have to combine these equations or these conditions, and then we will get the actual equation. And here the K is given K into K is equal to B into K 0. Okay. So, I can write that this is my beam equation and this is the two parameter model equation. So, now if I divide it into two parts, so I can write, if I divide it into two parts, so then I can write that this is my beam, over there is a UDL Q, and below that there will be a reaction is acting, and that reaction is say QB, and this is Q. Because this is a beam, I am now taking this is equal to the two on the two parameter model, and this is the two parameter model. So, this reaction will act over the two parameter model. So, this is QB. Okay, so, now I have separated this model, that means only two parameter model and the beam with the reaction. Okay, so, now if I write this equation, then the two parameter model I can write this will be QB, that is equal to K W minus G H d square W d x square. Okay. And for beam these equations will be now, because this is the reaction which is nothing but the K into W. In the actual beam problem I am writing K into W, that is nothing but this reaction QB. So, these equation, these beam equation I can write E I d 4 W d x 4 plus QB, that is equal to Q. Now, if I replace this QB here, then the equation will be E I d 4 W d x 4 QB is KW minus GI d square W dx square, that is equal to Q. So, I can write this equation is EI d4 W dx4 minus GH d square W dx square plus K into W, that is equal to Q. Okay. So, but in this equation, as I mentioned, this is K is equal to B into K0. Okay. So, K is equal to B into K0, but depending on what this two parameter model, depending upon the beam condition, whether it is a finite width beam or the infinite beam, then your B value will change. So, we can write that this equation is equal to, this equation I can write, that is EI d4 W dx4, that is equal to B star GH d square W dx square plus B star KW, that is equal to Q. Okay. Now, this equation is valid if your Q is kilonewton per meter. Okay. Now, if your Q is kilonewton per meter square, or if Q is equal to kilonewton per meter square, then these equations will be EI d4 W dx4 minus B star GH d square W dx square plus B star KW, this is B into Q. Okay. If your Q is kilonewton per meter square. So, most of the cases Q is kilonewton per meter. So, in that case this is the equation. Now, this is the equation. So, here this K expression is kilonewton per meter square per meter, because in this, just look at this equation. Here I have already multiplied the B with K0. So, that is why this equation is K into W, but here I have multiplied B dash. So, that will, because at, as I mentioned, at different beam condition this B dash value will change. So, that is why it is multiplied in this way. So, now if it is better for you, then you can write this is K0 also, which is the same as this one. So, K0 is kilonewton meter square per meter. Okay. So, now here I can write that, because when we are multiplying, this is QB. So, this QB we are basically multiplying by B dash or B star. Okay. So, this QB we are multiplying B star. So, this is also this is kilonewton per meter. So, this is basically I am multiplying B star with the K, I am multiplying B star with the GH also. Now, why it is B star? Because let me explain that. So, now this B star value has different conditions. Now, what is that conditions? Now, let me explain that thing first. So, that means the final expression is EI d4 W dx4 minus B star GH d square W dx square plus B star K0 W, that is equal to Q. Now, let me check whether this dimension is matching or not. So, as I mentioned, this expression is valid if Q is equal to kilonewton per meter. Okay. If it is not kilonewton per meter, then you have to use the second equation. So, it is kilonewton per meter. So, here it is B is meter, this is kilonewton per meter square per meter. So, into meter. So, this is also kilonewton per meter. Now, this term, this is meter, then kilonewton per meter square, G is kilonewton per meter square, H is meter, then this is d square W by dx square, W is meter, x square is meter square. Okay. So, that means this will be kilonewton per meter. So, again this will be kilonewton per meter. Here this is kilonewton per meter into meter, because B dash and the W. So, this is kilonewton per meter. Now, come to this part. This part EI is kilonewton meter square, then D 4W, that is meter, and x 4 meter to the power 4. So, that means here this is meter cube. So, ultimately this will be kilonewton per meter. So, that means we have to multiply this B dash in second term as well as the third term. Okay? Because third time it is obvious, because in our original beam equation this B is already multiplied, but that is if beam is resting on spring. But if beam is resting on 2 parameter model, then it is always not B. So, there will be something else. What is that? So, that is why it is written B star. Okay? It is not B, and that we have to multiply with the second term also. So, now this B star condition, that in case of plane strain problem, B star is equal to B, okay, width of the beam, and E should be replaced by E 1 minus mu B square. So, here not only B star, I have to write E star also. Okay? So, that means here what is E star? In case of plane strain problem, B will be equal to B, B star will be equal to B, and E star will be E minus 1 by mu B square, where mu B is equal to Poisson's ratio of the beam or beam material. Now, if beam with finite width, then B star will be equal to B 1 plus root over G H divided by B square K. Okay, and E star will be equal to E. Now, what is the difference between two cases? In case of beam under plane strain condition and beam with finite width. Okay. So, suppose if you have an infinite beam or you have a strip footing kind of foundation. Okay. Now, this strip footing kind of foundation you can analyze in two ways. One is beam under plane strain condition and beam with finite width. So, if beam with finite width, in that case length will be infinite, and if the beam is under plane strain condition, then your length will be finite. For example, first case I am considering that beam under plane strain condition or plane strain problem or plane strain condition. Okay? So, that means in such case this will be the length of the beam. So, if this is a strip footing kind of problem where this is the length and this is the width B, and definitely your L is much greater than B, because this is a strip footing kind of problem. Okay. So, if this beam is under plane strain condition, then this will be the length of the beam. So, length of the beam or length of the beam will be now the width of the footing, because it is under plane strain condition. And in such case your B, width of the beam will be unit 1. Okay? So, in such case your width of the beam will be unit, and this is one condition. And the next condition, if I consider that beam with finite width. So, previous case when I analyze the beam as a plane strain condition, that means this is width of the beam is not finite, because this is the width of the beam which is not finite, which is very large, infinite kind of thing, but it has a finite length. So, under this condition beam under plane strain condition, I can write that length is finite, but the B is not finite. Is not finite. Okay? And that is why we have considered during the analysis what B you will consider, because your B is not finite. So, during the analysis, if beam is under plane strain condition, then length will be equal to width of your foundation, that is B, and the B, as it is not a finite length or finite width, we have to consider as unit, that is 1. Okay? And in the second case, if your beam is with finite width, in such case your L is infinite, because beam has a finite width. So, L is infinite or not finite, but width is finite. Okay. So, in such case your B will be equal to finite width. So, width of the foundation, and L B will be equal to length of the foundation. Okay. So, that means the length is infinite or not finite, because it is very large compared to the width, and B will be the finite, and which is width of the foundation. So, under these two conditions, if beam under plane strain condition, then your B star will be equal to B, and generally it is considered as unit, and E star will be E divided by 1 minus mu B square. And if beam is finite width, even for infinite, so that means it is an infinite beam which has the finite width. For example, the railway track where the length is infinite, that means beam with finite width case. Second case where the beam has a finite width, but the length is not finite, That is the second case, that means I have written in the blue color. So, that means the length is not finite, but your width is finite. In such case, B star will be B 1 plus G H root over B square K, and E star will be equal to E. So, this is for the 2 parameter model. So, now if I go for the same thing for only spring. So, this is for 2 parameter model, 2 parameter, and this is for the only spring or 1 parameter. So, this case also the B star will be equal to B. Okay. And if your spring problem is there, so in that case your expression will be, I am just first writing the expression. If it is only spring, then the expression will be E star I d4 w dx4. This part will not exist because it is 1 parameter model. So, this will be plus B star k 0 w, that is equal to q. Okay. So, now if it is only spring under plane strain condition, B dash will be equal to B, okay, and E dash will be same as E 1 minus mu B square. And if it is finite width, second case, okay, because in such case G is equal to 0 or H is equal to 0, because it is the 1 parameter model, again B star will be equal to B and E star will be equal to E. So, all the problems that I have solved previously is for beam resting on spring and beam has finite width. So, that is why I have written B star is always B and E star is always E. But there is another condition, you can analyze the beam under plane strain condition also. In such case, if it is on spring, then B star will be the B, but E star will change. So, that means that if your beam is resting on spring, then whether it is a beam under plane strain condition or beam has finite width, then your always B star is equal to B, and that is why our general expression is always E star I d4 w dxs4 plus B k 0 w, it is equal to q, where remember that q is kilonewton per meter. Okay. So, now that is why this it is always B, but in previous expression I have not used E star, I used only the E, because most of the problems or all the problems that I have solved, I have discussed the beam resting on spring is for beam with finite width, that means infinite beam. So, that is why width is finite, length is infinite, is not finite. That is why I have written always E star is equal to E. Okay. But remember that if you are analyzing the beam as under plane strain condition, that means your length is finite, but width is not finite. In such case, you have to consider B star is equal to B, but in such case B will be equal to unit. So, ultimately when you multiply this B with k 0, so that means your B will be unit in that time, clear. So, you have to multiply with k 0. So, basically in such case your k 0 will be equal to k, because B is unit. Only the k 0 and the k unit will change. K 0 unit will be kilonewton per meter cube and k unit will be kilonewton per meter square, because as we have multiplied with a 1 meter unit with the k 0, clear. But if your but all the cases, if your beam is under plane strain condition, remember that you have to replace E also, E by 1 minus mu B square, whether beam is resting on spring or beam is resting on 2 parameter model. So, if beam is under plane strain condition, then you have to replace E star under both the conditions. That means, beam is under on spring or beam is on 2 parameter model. Clear? So, that means, here these equations you have to remember that this is the general equation for beam resting on 2 parameter model, and then how to convert E star and B star depending upon which condition you are analyzing your beam. Okay? So, now next one that I have discussed, that under plane strain condition, all these things I have discussed. Now, I want to discuss that these problems, that means, here these problems are general equations. I mean, these equations are general equation. Here I have not I have discussed, that means, you can use them with infinite length, you can use them with finite length also. Similar way, the equations of this spring case, that means, these equation also. This is also general equation, you can use them for finite beam, you can use them for infinite beam also. But I have discussed that how you can solve that when beam is resting on spring for infinite case as well as a semi infinite case, and the similar way you can do it for the beam with finite length case also. But now I will discuss, or in the next class I will discuss, that how I can solve this general equation for different loading conditions and different beam conditions. I mean, whether it is a finite beam or infinite beam, by using numerical technique, and I will concentrate on finite difference technique only. So, in the next class I will discuss that how these equations can be solved by using the finite difference method.